Let's look at page 367. Springboard page 367. Now, I'm not exactly sure why, but for some reason I forgot to assign you homework about angles whose vertex are outside of the circle, because we learned about 4 last class. You have your central angles, you have your inscribed angles, you have the angles whose vertex is inside the circle, and then the last was angles whose vertex is somewhere outside the circle. But we need to know how to solve problems with these type of angles. So we're going to take a little bit of time in class today to practice these. So on your own, I want you to do C and D. Not A and B, but C and D. Can someone raise their hand and remind the class how the measure of the angle is related to the intercepted arcs? What's up, man? Half the difference. So, this angle measurement, that angle intercepts 2 arcs. This one and that one. The rule is that that angle measurement, whose vertex is outside the circle, is 1/2 the difference. Okay, so quickly, C and D. Okay, let's go over part C and part D. It says find x, which is representing the measure of the angle whose vertex is outside the circle, if A, the measure of this arc was 160, C, the measure of this arc was 80 degrees, and, D was 70, representing that angle mark. Now, you should know, we just discussed that the measure of the angle is 1/2 the difference of the intercepted arcs, because there are 2. You've got this intercepted arc and that intercepted arc. That angle intercepts 2. So we need to take the difference. Is this correct, what I wrote on the board? I'm taking the difference of them. Why is this wrong? I'm taking the difference. It's because I'm taking the smaller and I'm subtracting the bigger. That's not the way that works. You need to start off with the larger arc and subtract the smaller one. So let's go ahead and plug in what we know. We're trying to find x, that's good. We have that the measure of arc that's represented by the variable a is 160, but then we have b. We can't have 2 unknowns. We can't have b and x in one equation. So we need to use our deductive reasoning. Go ahead and solve for the measure of this arc that's represented by the variable d. We're just going to have to use the arc addition postulate, part plus part plus part plus part equals whole, however many parts you have. So we have 4. This entire circle is broken up into 4 parts. 1, 2, 3, 4. So part plus part plus part plus part equals 360 degrees. So we'll take 360 degrees, subtract 80, subtract 60, subtract 70, and what is left over? 50 degrees. So now we just solve. So x is 1/2 of, this is 110. So x is 55 degrees. Questions on part C? Yes, sir?
Would we have to put a measure in the x or just x?
I hate everything about this notation. We can't say the measure of angle x because x is not representing the vertex name. Like, it's not labeling this point as x.
Okay.
Traditionally, what they'll do in diagrams, most textbooks will have, this is x degrees, b degrees, c degrees, a degrees, d degrees. And so your answer would just be x is 55. So that when you plugged it in, it would be 55, and degrees would already be printed there. So this is just weird. Yeah, just weird. But rather be safe than sorry. So on quizzes and tests, go ahead and throw degrees in there. Rather be safe than sorry. And if we match their notation, it says A is 160 degrees and C is 80 degrees and X is 35 degrees. So we should have put it there, just matching their notation. Okay, D, write an equation and solve for T if A was 10T and B was 3T minus 10, and then this was 4T minus 1. So once again, we have X is 1/2 the difference of the two intercepted arcs because the vertex of the angle is outside the circle. That's why we're taking 1/2 the difference. So plug in what we know. This is 4T minus 1 equals 1/2 times 10T minus 3T minus 1. And I'm sure this is what everybody wrote. However, we are subtracting this entire arc measurement. We are subtracting this whole thing. So, simplifying what is inside the set of parentheses, I've got 4T plus, 4T minus 1 is equal to 1/2 10T. If I subtract this entire expression, it's going to be negative 3T positive 10. You must distribute that negative sign. You're subtracting the entire expression. So you must subtract 3T and you must subtract a negative 10. Whenever you subtract a negative number, it's like adding. Okay? So we've got 4T minus 1 is equal to 1/2. This is going to be 7T plus 10. Now rather than trying to distribute this 1/2 and me get decimals and fractions, because 7's not even, I'm just going to multiply both sides of the equation by 2. And when I multiply both the sides of the equation by 2, I'm going to get 8T minus 2 equals, well, the times 2 and the 1/2, that would simplify down just to 1, so we get 7T plus 10. Subtract 7T on both sides, I get 1T. Add 2 to both sides, I get a positive 12. Positive 12. Okay, moving on to the next page. Let's take a look at, just move to the next page, 368. 368. We're going to do number 11 together. We're going to walk through this extremely slowly. Okay, so for number 11, it's a mixture of inscribed angles. So you have an inscribed angle right here, angle 2. And then an angle whose vertex is outside the circle, angle 1. This is a very difficult problem. And it's only going to get more complex from here. So this is a basic version of the complex problem. Number 11, determine the measure of angle 2. So in the end, we need the measure of angle 2. And we are given that the measure of angle 1 is equal to 34 degrees. We just need to start writing down some equations that we know are true about angle 1 and angle 2. The issue is we have a lot of unknowns. We have no idea what the measure of angle 2 is, and that's our end goal, is to find the measure of angle 2. We also have no idea what the measure of its intercepted arc. So angle 2 is intercepting this arc here, and we have no idea what that is. Y degrees. We also can't solve for what is y because we don't know what the measure of this arc or this arc. I call that z, the whole thing. But what can I say about these two arcs that are currently on the board. If I add up z plus y, that will equal 360 degrees. But we still have three unknowns. No idea what the measure of angle 2 is, no idea what z is, no idea what y is. But there is a relationship between the angle that we do know, 34, and then these two pieces of the circle. So can someone tell me that? What is the measure of angle 1 equal to with respect to these variables that we have added in to our diagram? One half, what? The difference. Okay, so can someone just say, sweet, fantastic. I just wanted to make sure that we understand the order. So yeah, in the end, we know that the measure of angle 1 is equal to 1/2. I'm going to try to make my 2's not like my z's. 1/2 times this difference of z minus y. Well, we can plug in 34. But the issue is we still have two unknowns. We have z and y, two unknowns, and we have z and y up here, two unknowns. I'm just going to go ahead and erase this guy because it's the same thing. I just replaced the measure of angle 1 with 34. What do we do when you have two unknowns? What is that called in Algebra 1? This is a system of equations. Okay? This is a difficult problem. It is, okay? Because you're dealing with angles whose vertex is outside. You're dealing with angles whose vertex is on the circle. So that's two different types. You got to remember how they're related to the intercepted arcs. Then you're not given anything about the measurements of either one of these arcs, and so we have to set up two equations, make up variables, and then now we're tapping into Algebra 1 with systems of equations. So you have to remember how to solve the systems of equations, either elimination or substitution. So this is absolutely a PreAP question. These are our two equations. I'm going to manipulate this guy just a little bit. If I multiply by 2 on both sides of the equation, that's justified by the multiplication property of equality. If I multiply by 2 on both sides, then I'm going to get that this is 68. And then, if I multiply by 2, then the 1/2 and the 2 cancel out, and I have got z minus y. Now, I'm going to use the symmetric property of equality. What does the symmetric property of equality allow me to do? Yeah, just interchange whatever's on either side. The reason for that is because I want my variables on the left and I want my constants, 68, on the right. And now it looks very similar to my first equation. So I'm going to pop over here and we're going to solve this systems of equations. I've got z plus y equals 360 degrees. That's just adding up the two arcs. They make up the whole circle. Then, using the fact that the measure of the angle is 1/2 the difference, and we manipulated this equation a little bit, this gives us our second that says, well, when we take this difference, it's going to equal double the angle, right? If the angle is 1/2 the difference, then just reverse that train of thought and say, well, then the difference is double. It takes 2 of the angles to equal the difference. And so that's why we're taking 34 times 2, and that is 68. When I have it set up like this, we can just easily use elimination, that technique to solve systems of equations. And that is when you basically just put a giant addition symbol and you combine them, but you make sure that one of your variables has coefficients that are the same number but different signs. So this is a positive 1, this is a negative 1. And so if I were to combine these two equations, 1z plus 1z is 2z. It sounds like I'm saying 1z. Like a onesie? Like I wore a onesie last Saturday. Anywho.